lots of different kinds of compounds that have been classified in chemistry. You guys have already, or we have already broken up all of the compounds into two kinds. What is the division that we've made in the chemical compounds already? Ionic and covalent. Good. So the ionic ones, we've got covalent ones. Covalent. They are determined by how they're bonded together. So ionic ones are a positive and a negative ion. The covalent ones are both negative. They bond by sharing electrons. Could I zoom in? Not far, because I need the whole page on the screen. We've talked about a few different kinds of compounds already. I mentioned these to you. There are organic compounds, There are inorganic compounds, so I haven't really talked about those at all. Organic compounds exist or are defined because of the CH and O they contain. Inorganic are the other ones. Even within these various separations, categories, we can break things apart further. Within the organics, the organic compounds, there are hydrocarbons. So things made up only of hydrogen and carbon. For example, methane. Methane is CH4, gas produced when you fart. So that's a hydrocarbon. Propane, you use this C3H8, propane. You use it to barbecue things, power your car, heat your home, perhaps, among other things. Then there's also alcohols. I don't just mean consumer alcohol. There's all sorts of different kinds of alcohols. They're organic. And then there's ethers, which I've mentioned to you guys already too. Ethers are found in perfumes, for example. Michael, where's your booklet? Get your stuff out. I asked you to get your notes out. Find this page. I know there's only 15 minutes left. I'm going to use them. You need these notes. There's organic and there's inorganic. There are oxides is another one. Even within the oxides, there's two different kinds of oxides. Oxides are just compounds that are reacted with oxygen. So you can have both metal oxides, you can have non-metal oxides. The metal oxides are, I'm hoping it's obvious, ionic. Metals are positive, oxygen is negative, so when you have a metal oxide, you have an ionic compound. If you have a non-metal reacted with oxygen, the non-metals are negative, so is oxygen. You're going to have what's called a non-metal oxide. Those things are covalent. Got a negative charge and a negative charge. And when you react some of these oxides, both the metal oxides and the non-metal oxides with water, you get what we're going to talk about today. So the metal oxides are going to create for us, I'm going to go, which way am I going to go? I'm going to go this way. The metal oxides are going to create for us bases when we react them with water. The non-metal oxides are going to create for us acids. And when you take an acid and a base and you mix those guys together, you add those, you create a salt. So there's all sorts of different classifications for these chemicals. We've looked at a few of them already. And today we're going to talk about acids and bases specifically. So early chemists recognized that a few groups of substances each shared common properties within their groups. One particular group shared the property that all of them had a sour taste. You will not be tasting things in the lab because I'm not going to let you. you look at the bottom of your page, Soham, it says, for obvious safety reasons, we do not rely on taste tests to classify compounds in the laboratory. But at the birth of chemistry, they didn't know that. Jeff had to die, and then Joey had to get sick, and Frank over there, we thought he was dead, but then he came back from tasting all of these different things. Okay? We don't taste things in the lab. We lost a bunch of good people along the way. They all shared a sour taste, and back then they said, okay, well, all these sour things, we're going to group them together. We're going to call them acids. And you guys perhaps are familiar with some of these sour tasting acids. Citric acid is one of them. Citric acid in a liquid form is in any citrus fruit, orange juice, lemon juice, lime juice. It's why if you take a peel and walk up to someone you don't like and squeeze the peel in their eye, it's going to burn. It's wildly or maybe you're going to do it to someone you do like. You walk up to your best friend, you squeeze an orange peel in their eye, it will burn their eyes because what you're doing is you're spraying them with citric acid. When you've all experienced this. Yesterday, I was picking up my daughter from daycare. No, you haven't experienced this part. I was picking up my daughter from daycare. She was complaining of her stomach hurt. I thought she hadn't had a snack yet. I thought she was just a little bit homesick. I picked her up, I gave her a hug, put her in the car, and we're driving home. She moaned a little bit in the car on the way home, and I turned my rearview mirror down to see her just in time to watch her projectile vomit all over the back of my driver's seat and the back seat and herself. And if the headrest wasn't have been there, it would have hit me. It was impressive for a 4-year-old. It was disgusting, but it was impressive. And when you've all thrown up, I'm assuming at some point in your life, perhaps recent enough to remember it, both the taste, if you can forget the added bit of what you just ate, but the taste and the smell are both sour. They're awful smells, but they have a sour smell to them and a sour taste to it. This is because when you're throwing up the contents of your stomach, and your body produces an acid in your stomach. Does anyone know what that acid is? Can you be more? Well, we call it gas. You're being funny. We call it gastric acid, but it has a chemical formula. Does anyone know what it is? It is HCl. Hydrochloric acid is what your body produces to digest its food. And so you all experienced this. Some of us more recently than others. But they all have this thing in common. There was another group that they kind of isolated with these properties. They said this particular compound feels slippery. It was a good cleaner. They say, okay, we took the slippery thing, we put it onto the dirty thing, and the slippery thing cleaned the dirty thing. That's weird. And they all tasted bitter. They called these chemicals alkalis. And if you look at where and we call them bases. And for those of you who remember think back to Science 9. The two columns on the left of the periodic table are called what? The alkali metals and the alkali earth metals. Good. Well, and up here I said, if you have a metal oxide, you create a base. Specifically, those metal oxides are the left two columns on the periodic table. You take those, you react them with oxygen, you dissolve them in water, and you're going to get a basic solution, something that you could use as a cleaner. This should be the word in. In the 1800s, a Swedish chemist named Svante Arrhenius, I love that name, it's great. Svante Arrhenius recognized that the presence of ions in the solution really was a better distinguishing factor between what made an acid and what made a base, and the relationship there he used to classify these. His definition, which we got in 1903, so 128 years ago, relatively recently in the world of chemistry, he gave us this definition, and then we're going to be done for today. He said that acids are any compound that produce H plus ions when dissolved in water. And bases produce OH minus ions when dissolved in water. He looked at all of the things that they called acids and bases dissolved in water. He looked at all the things that we said are acids and bases. He looked at their formulas and he said, interesting. They have something else in common. Acids produce H ions, bases produce OH ions. Harleen, you're grade 12? Damn. Okay, never mind. There is another definition that I thought Harleen could give us, but I forgot she wasn't in grade 12. That you will learn. There's a newer definition for acids and bases. You will see in grade 12. Yes. This is not the 130-year-old definition is not the end. There's a newer one coming, but for now, this is a great place for us to sit. Grade 12. Specifically, if you don't take chemistry, you're never going to see it. Because I don't need to. You learn in grade 12. Or you could Google it. This definition is the one that we're going to work with here, and so that's the one I'm going to leave you with. Okay, you can pack up. We will finish this tomorrow. When the bell goes, you may also go. Have a super duper day. We'll see you later. Okay, you want to know what it is? Okay. So, the new definition, what is a hydrogen ion? What is a hydrogen ion? What is it? Don't look it up. Think about it. So hydrogen, an atom of hydrogen. Atoms are made up of protons, neutrons, electrons. What's the number for hydrogen? Which means it has how many? 1 proton. What's the mass on hydrogen? It's 1. Which means that a proton atom has no neutrons. It just has protons. So a H plus ion is a hydrogen ion that has lost its electron, which means a hydrogen ion is only what? No. Hydrogen? It's only proton. It's a single proton. A hydrogen ion is just a single proton traveling through space. So these two chemists, Bronsted and Lowry, redefined this to say, well, forget that we're talking about H plus ions. What are we actually talking about here? We're talking about something that donates a proton. Donates a proton. No, a hydrogen plus ion is a proton. That's all it is. It's a single proton. So anything that does this, that donates a single proton, is by definition an acid. So they don't talk about H plus ions anymore. They talk about the donation of a proton. And that opens up things to get more complicated. Right before the bell, because Chalo, Sale, and Walter are in the office. Please wait for the bell. Okay, see you guys later.